What if I told you the end of the world could be caused by something smaller than your finger? Not an asteroid, not a comet, not a black hole, a needle, an ordinary sewing needle, moving at the speed of light. We're used to fearing massive threats from space, gigantic explosions, planet-killing rocks, cosmic forces we barely understand. But the universe doesn't care about size, it cares about speed. Earth is hit by space debris every single day. Most of it burns up before we even notice. Sometimes larger objects make headlines, like the Chelyabinsk meteor or the asteroid that wiped out the dinosaurs. But here's the truth. Compared to the universe, all of those objects were slow. The Chelyabinsk meteor traveled at around 60,000 kilometers per hour, fast, but nowhere near extreme. Now imagine this headline. An unknown object is approaching Earth at nearly 300,000 kilometers per second, the speed of light, and it's no bigger than a needle or a grain of sand. Sounds harmless. It's not. Speed turns nothing into everything. A slow-moving car might injure you. A slightly faster one can kill you. At light speed, physics stops feeling intuitive. Light, radiation, and energy move this fast. Matter technically can't. But let's imagine it could, just for a moment. A sewing needle is about 35 millimeters long, a large grain of sand, about 5 millimeters. For comparison, the Chelyabinsk meteor was 20 meters wide. The size difference is ridiculous, but at this speed, size becomes irrelevant. At near light speed, the needle wouldn't burn up in the atmosphere. It wouldn't slow down. The atomic bonds holding it together would fail. It wouldn't be a solid object anymore. It would be a stream of particles. And what really matters now is kinetic energy. A single grain of sand moving near the speed of light would carry as much energy as a 100-ton object falling from a 15-story building. All of that energy released in a fraction of a second, which means one thing: an explosion. If a needle struck Earth at the speed of light, the energy released would be comparable to a nuclear bomb, around 43 kilotons of TNT. For perspective, the atomic bomb dropped on Nagasaki was about 21 kilotons. An everyday needle with more destructive power than a weapon that erased an entire city. Let's say it hits Manhattan. Most of the city would be destroyed. Windows would shatter kilometers away. Severe injuries far beyond the impact zone, and unlike a bomb, the needle could penetrate deep underground, creating massive internal damage. Shockwaves, collapse, chaos. But there's an even darker possibility. The needle doesn't stop. It pierces the planet. A plasma cloud erupts at the entry point. Energy races through Earth's interior. Matter explodes out the other side. If enough energy transfers, Earth's gravitational binding fails, and the planet tears itself apart instantly. No warning, no survivors, all because of something you could barely see. Not all scientists agree. Some believe the needle would pass through Earth so fast that most of the energy wouldn't transfer at all. It would enter, exit, and vanish into space. Earthquakes might follow, but nothing world-ending. Humanity survives. But what if it doesn't hit the ground? What if it hits you? The odds are tiny, but not zero. At first, it sounds unsurvivable. But physics gets weird at extreme scales. Because of its speed and size, the needle wouldn't dump all its energy into your body. It would pass straight through, breaking molecular bonds along its path. The result? A nearly perfect hole. Minimal heat, no explosion. Against all intuition, survival is possible. So should we be afraid of needles traveling at the speed of light? Probably not. But this thought experiment proves something terrifying. In the universe, speed matters more than size, and sometimes the smallest things carry the power to end everything. If questions like this keep you curious, if you want to explore the dark, strange, and hidden side of reality, this channel is your place. Subscribe, because the next question might be even more disturbing.